Today I'm going to show you a technique that I use to create variations on parts, such as this flat back that makes it easier to 3D print on my desktop machine for testing designs. Welcome to another episode. Before I get into the details of this episode, I want to show you a video from last weekend. I live in Western Washington state, and it's usually pretty temperate here. We don't get a lot of snow during the winter, but last weekend we certainly got a lot of snow, and it was pretty cool. I like it when we get snow like this and then it's gone in the next day or so and things are back to normal, because it's really fun to watch the snow fall, but it's not so much fun to have the snow linger, especially when we have steeper hills that make it difficult to get up and down the hills. This is a CAD file I've been working on for a while. It's for a remote control for model trains, and this will be injection molded, and the molds will be created by a company in North Carolina. But I want to test this typically to make sure that the fit is correct with the circuit board and the knob and other things before we start to cut the metal. And I have a regular desktop 3D printer. The thing about desktop 3D printers is that you need to make holes a little bit larger. You can't have a curved back like this without support. And one of the problems with using supports, as you can see here, is the supports also go up into the holes. And these supports can be difficult to remove cleanly. So one technique that I've started to use is to basically cut the back into two pieces to create a flat area that is easy to 3D print, and then I can take the other part, 3D print that as well, and then glue the two together. Now, I could make those changes directly in this file. The problem with doing that, and the reason I don't like to do that, is because sometimes I forget to disable those changes, and then I send the files to the injection molded company that have changes designed for 3D printing, not for injection molding. So let me show you the technique that I use instead. The trick is to use Insert Derive, and I will show you, or Insert Derive, and I'll show you how that works. I'm going to start by creating a new file. I've already done this, so I'm just going to walk you through these steps. Actually, let me show you the result first. So if I go here, I have a file which is already set up, and I'm going to turn on component color cycle, because it makes it a little bit easier. So you can see I've cut the bottom off and I've increased the size of the holes to make this easier to 3D print. And I'll go ahead and recreate that from scratch. So I'll create a new design and then save that, because you have to save it. And I'll just call this test so that I remember to delete it later. Now that I've saved it, I can insert derive. And for this, I want to insert from this file here one of the components. And okay, this is something I've run into. If I haven't saved this, then it doesn't really work the way I want. So I need to save this, make sure it's saved, and then come back here, say insert derive again, and then I can select that file. Once I open this file, it's going to ask me to select a component that I want to pull in. So I'm going to grab this one here, which is the back. And now you can see I have the back in my file here. I'm free to modify this without impacting the other file, and I'll show you that with the changes I'm going to make. So the first thing I mentioned is I want to cut the bottom off. I'm actually going to split it into two parts. So I'll create a sketch here, and then I'm going to project this at the bottom so that I can decide where I want my split line to be. Now, I've got an idea of where I want my split line to be based on some other elements. So what I'm going to do is project those as well. So I don't want it to be too thin, and so what I'm going to do is project this onto the sketch so that I have my split line below that, and I'll actually just go ahead and add a dimension so that it's controlled. You don't have to add a dimension for this type of thing, but I think I'll make it 0.4 millimeters so we have a couple layers. I'm using a layer height of 0.2 millimeters. That gives me my split line. So now I can go ahead and say split body. I'll select this body here, and I'm going to use this as the splitting tool. And once I do that, you can see that I have two bodies here. One body is actually three bodies. So I have the shell itself that I can now print flat without any problems on the 3D printer. And then I have these other two pieces that I can print separately and then glue to the back of the main piece. The other thing I want to do, as I mentioned, is increase the size of these holes. I typically like to increase the diameter by about 4 millimeters. That turns out to give me the fit that I really want. So I can just go in here and select this. I'll project with construction, and I'll select all of these holes. Okay, that will give me dotted lines here. And now what I can do is I can go to this and I can say offset. Turn this off, construction, so now it's a solid line, and I want to make the offset 0.4 millimeters. And then I'll go ahead and do that with all of the others. All right, I finished the sketch, and now I can extrude those. And I have larger holes. So that's pretty much all I need to do to this part to be able to print it. Now let me show you a feature that is in this version here. So I'll go ahead and select the back and isolate it. And there's a element that I added fairly late. So what I'm going to do is I'm going to disable, I think it's this one here, I'll roll back to it. Yep, I found a flaw in my previous design, and I know what I'll do. I have a little bit of a angle that I put on there, so I'll just disable this piece here. Suppress feature. I'll roll forward, and then I have to save this. I'm going to have to make sure I undo this after I'm done with this demo. So now when I go back here, for some reason it doesn't show that there's a new version. I'm not sure why. But if I right click on this, I should have the option to get the latest version. So let me go back. Oh, it didn't save it for some reason. So I'll go ahead and save it again. Okay, now it saved it. And then when I go back here, as I was saying, one thing is it doesn't show that there's a new version like it does in other cases. But if I say here, go ahead and get latest version, what's interesting is it doesn't show here. I have to click here. I'm not sure why. But if I do get latest version, it takes a little while, but you can see, okay, that didn't work. I should have gotten the version without the angles. Aha. Okay, I thought I disabled it. And I did. That's very odd. Fusion is doing something very strange to me at the moment. Okay, I disabled the wrong feature. All right, let's disable this feature. And again, I'm going to undo, and then I'm going to undo these things when I'm done. Okay, so now when I save this, and go back to here, and say, get latest version, You'll notice that it came in with only half of these ribs, and with that element not there. And if we look back, you can see that matches what we have here. So I'm going to go ahead and undo this now, the changes that I made. Okay, so it's back to where it was. I was just using Control-Z, which is the same as clicking undo here. So I went back to when I did the isolate. And now when I come back here, again, I can say get latest version. And it's back to the way it was. So this is a really, really nice way of being able to have two different versions without having to modify the original version. This is nowhere near as nice as SolidWorks, which has configurations that work much better, but it's kind of the very poor man's version of the SolidWorks configuration feature. There's another place where I have used this. So I have this knob right here, and we decided we're going to ship two versions of the knob, one with this orientation and one with the opposite orientation, which you can see here. So this flat right here is next to there, and if we look at the other one, the flat is away from that. To do this, this is the original file here, and I created a derived version here. So I have Insert Derive, and then I have some operations that basically took features from the original file and then add new sketches to recreate this. And you know, this was a little bit of a pain to do. There might be an easier way that I haven't figured out yet to simply rotate this, but you can see that I'm kind of rebuilding it by moving the flat part to the other side one step at a time and adding the fillets, etc., until I have the final version. So here's one of the backs that I 3D printed. This one has a little bit of warping back here that I just noticed, but it still works and serves its purpose. And the purpose is to test how it fits with, you know, the rest of the parts. So what I can do is assemble this and put it on the right way. And then I've got some screws in here that hold it together. I'm just going to put in a couple at the moment. And this allows me to make sure that the circuit board is in here well. And one of the things that I discovered is that I thought it was in here correctly, but it actually wasn't. For one thing, you can push down on this. And so I made some changes to the design that I'll show you in just a second as a result of that. But the top, I did not reduce the size of some of the parts, so the circuit board is kind of sticking to the top. And when TCS had some prints done by Shapeways, they were much more accurate. And then they discovered that the circuit board wiggled back and forth a little bit, which is why I added that element that I'll show you again to fix the design. But the real thing that we noticed is the keys were not sticking out as far as they should have been. And that was the indication something wasn't correct. So I'll take you back to the computer, and I'm going to show you another technique that I use when I'm trying to figure out what's going on wrong with the design. There's another feature, a few more features of Fusion 360 I haven't shown before. One is that I've set up a separate team for collaborating with TCS, which is Train Control Systems, on their throttles. So that means I can switch to their section, and now I can open these files, they can open these files, and so we can collaborate. And that was really useful, for example, with the circuit board, because the person doing the circuit board was able to import it into Fusion 360 and create a version of the circuit board that has all of the different components, which is really nice for making sure that the case does not hit anything that it shouldn't hit. Anyway, going back to this right here, I'm going to close this file. And what I'm going to show you is yet another Fusion 360 feature. I am using something called Milestones to mark a version. And what that means is that I can open the version before I fixed it for the wiggle in the circuit board. So I'll go ahead and open that version. And then I'll isolate the back for just a second. And you'll notice that, let me turn on component cycling again. You'll notice that the rib does not stick up. That's something I missed in the design, and I'll show you how I was looking at things, which is, I have since discovered, not the best way to look at things. So I was kind of looking at things like this, with one component selected and the transparency to try to figure out how everything fits. That's really not the best way to do it. A better way to do it is to use section analysis. So what I can do is say inspect and then section analysis. Select here, and then what I can do is I can drag this over until I can see the rib. Actually, this should work fine here. Because what I can see from this is that the circuit board has a gap between it and the rib. So that's something I needed to fix. I'll go ahead and close this version and then open the latest version. And I already have that section analysis, I believe, so I just need to enable it. Okay, so with this one enabled, what I can do is I can go ahead and edit it, and then move this over a little bit more so that I can see the rib in the circuit board, which is right there. And now you can see that with the addition that I made, I'll turn off the section analysis and show the back, which is this part here that comes out, up and out. Now I have the fit and finish that I want, where the rib is correctly pushing up on the circuit board. I also mentioned that I was able to push down on this, and the circuit board was bending a little bit as well as moving up and down here. So I changed the locations of the ribs. I added another rib here to support the circuit board below the screen and to make sure everything is rigid. So the next step is I'm going to do a 3D print of this, do some testing. TCS is going to do another shapeways print, which will be more accurate, and we'll do a final round of testing and everything should be okay. The final thing I'm going to do is I'll switch back to the desk and show you the knob, which is a follow-up to a previous episode I did on the knobs. I got in the D-springs. In the last episode I mentioned I was going to use D-springs in here. And so I tweaked the 3D version of it, the desktop printable version I should say, until this, if I can get it in straight, this goes in without too much force. And then once I've done that, I can line this up with a flat, and then it just pushes on there. Now this is the encoder version, and you can hear that because I can push this in, and also it rotates all the way around. In case you were wondering, this is an opening for the programmer so that I can initially set up this circuit board and bring it online. Once it's online, then we do everything over the air. I hope you enjoyed this episode. Please subscribe, give me a thumbs up, comment below, and I'll see you next time.